Hello everyone. Today is the 24th day of Leetcode 75 challenge. Let's begin with the 24th question. Question 2390. Removing stars from a string. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. So you are given a string S which contains lowercase letters and some asterisks. Fine. Each asterisk in the string works like a delete button. So what it does, it basically removes itself, first thing. It also removes the closest non-star characters to its left. But it's trying to say, since we are having all lowercase letters and we have stars also, right? It's saying that each asterisk removes itself. So this removes itself, fine. It also removes the closest non-star character to its left. So this is a non-star character, so it also gets removed. And this removes itself, and then the non-star closest becomes this one, so it gets removed, right? So we need to perform this operation for all stars in the string from left to right. Now the input is guaranteed to be such that every star has a character to remove on its left, so there won't be any invalid case like you received only stars and there is no character before it, right? So there won't be any such kind of case. And your goal is to return final string after all such operations have been completed, and the final string is always uniquely determined. Fine. So question is pretty easy. You are given small, strings of small characters and asterisks, and you have to just remove the asterisk and the value which is just previous to it. Fine. That's all, and which is not an asterisk. Now let's come to the constraints. The length of the string is 1 to 10 to the power 5, and S consists of lowercase English letters and stars only, or we could say asterisks. The operations above can be performed on S. Fine. This is the thing. Now let's move to the next slide. Now let's understand the input-output explanation. So here you can see you're given lead, then star or asterisk. I will call it asterisk. Okay, this fine. So output is Leetcode. Okay, so how? If you can see, it was said that if you remove this, we if you get an asterisk, we remove that, and the previous or the closest non asterisk character to it. Fine. So T is the closest here, so it gets removed. So it becomes Lee asterisk code asterisk and then E. Fine. And here also asterisk will get removed and D will also get removed. So it will become Lee asterisk code E. Fine. Here also this E will get removed and this asterisk will get removed. So it becomes Lee Koi. Right. This is what we got. Right. The question is pretty easy. If you can understand this explanation. Right. So now let's take the example 2 also. Here we are given erase. Fine. And how many asterisks are there? Five asterisks are there. Fine. One, two, three, four, and five. Fine. Please excuse my asterisk drawings. Suppose you understand these are five asterisks. Fine. So this asterisk will remove this e, then it will become erase and with four asterisks, right? So this will remove this r. This asterisk will remove this a later on. This will remove this r, and this asterisk will remove this e. So at the end, we will just remain with the empty string. Fine. I hope you understood the input-output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. Let's do it by imagining a person whose name is Sam and who is writing a message on a piece of paper. Let this be a paper and left can be a message. Every time Sam writes a letter, okay, which is in a piece of paper, it gets added to the paper. Fine. Okay. So what the question is trying to say, this is a paper, and every time Sam writes a letter, it gets added to the paper. Just it's like writing something into a paper, right? He wrote M, it got added to the paper. Fine, he got added to the paper. But here's a twist: Sam sometimes messed up and hits undo button, which is represented by a asterisk symbol. Now, okay, so like MEIY. Now he remembered that okay, I didn't have to write Y, right? So he will click undo. Now, if you remember, if you're doing any drawing in art clip or something like that, you drew a house, right? And Now you remember, okay, I needed to draw, I draw a chimney here, but the chimney should not be of this shape, right? So you click undo. Now what happens in undo? It does not remove the house completely, right? Or it does not remove the roof or something like that. It will remove the last edited thing, which was chimney in this case, right? So the chimney gets removed, right? Or if you take another example, suppose you write a statement here, hey, welcome to YouTube, right? Now you remember, okay, YouTube has to be written in complete word, right? So you click undo. So what happens? The YT or the YouTube short form gets removed, not the complete statement. So what does it signify? It signifies that whenever we click undo, the recent most uh, thing you did, right? It could be writing, it could be drawing, it could be anything or modification that gets removed. And the number of times you click undo, that you could say that the most recently used gets removed. For example, X, Y, Z, U. So you click undo, this gets removed. Then click undo, this got removed. It's not like that. When you click undo, the X will get removed because in the queue, Y comes first. Fine. Okay. If anyone is here who got any understanding that where we are heading towards it, I will request you to move ahead. But if someone who has think still having a doubt, that's what I'm trying to explain here. Let's move more into the intuition part. Okay. Now let's understand the goal. Right. Sam wants to write a message using letters and can remove last letter every time he sees a asterisk. Fine. The star does not go into the final message. It's just a signal to remove most written recent letter. Fine. Okay. For example, Sam writes something like "Hey" or he writes a letter. Does not take a word. Let's take letters. He writes I A M S A. Now he remembers that he encounters an asterisk here. Fine. Right. It does not go into the final. Here we can see that every time, every letter time he sees an asterisk, it gets removed. Okay. So he sees, okay, an asterisk is here, right? So what he does, he removes or he does the undo part. Undo part means A gets removed. Fine. Then he moves ahead. Then he checks like he adds a U M. Then he gets encounters an asterisk, right? So this means he have to remove M again. Correct. Now this is the thing. Now let's take to make it more clear. Let's take another thing. Suppose this is a letter it's using, right? So S is here, right? He throws the S here, or you can say that he have a statement SAUY star Z then K and then star star. Okay. Now look, S is there. He thought of putting S into the paper, the sheets of paper, right? So let me remove this. Let me draw it properly. Let this be the sheet of paper. So he encounters S, he writes S here. When he encounters A, he writes A here. He encounters U, he writes U, Y, then Y. Then he encounters asterisk, which means he have to undo. And undo means undoing only the last or the most recently updated thing, right? So most recently updated was Y in this case, right? So you remove Y, fine. Again you encounter asterisk, so you remove U, fine. Then after that you encounter what? Now encounter Z, then you encounter K, right? Then again you encounter asterisk, so K gets removed, again asterisk, K gets removed. So finally, in his piece of paper, he just has what? SA, right? So if you have observed what we are trying to do, we are just putting the stuff in the piece of paper, and whenever we encounter an asterisk, we remove the most recently used. So basically, the thing which was put it at the end in the current timing gets removed first. Fine. Am I making some sense here? For example, If I'm making any sense, can you just recall any data structures which can be used here? It's a very simple, intuitive thought here. What we are trying to do, we are removing the most recently used character, correct? We're removing that character, or we are using, or we could say in another language, the the last character entered is removed. First, fine. The last character which you entered in the, you could say, the piece of paper is removed first, right? Whenever we find an asterisk, and it is only done one time. One asterisk, one character. Five asterisks, five characters, right? That's the thing. So this basically uses the concept of stack. Yes, we are using the concept of stack data structure here for implementing this problem. Because what stack says, or we could see what is the philosophy of a stack. Stack says that last in, first out. Correct. Correct. And what I said before, last character in is the first character which was getting out in our intuitive build-up, right? Here also we can see that last character entered is removed first, right? Or most recently used character is removed first. So the most recently used is basically the last character only, right? So how stack works? Stack works. You keep on pushing the stuffs, and when you pop, it gets removed. It gets removed. It gets removed. It gets removed. Right? This is what how a stack works. Fine. So we use stack, which works like a Sam's paper, last written, first erased, right? For each character in the string, it's a letter. We push it into the stack. Suppose we have C, A, B, asterisk, asterisk. Sorry for the asterisk. D, E, F. Fine. So how it works? If it's on a character, we try to push it into the stack, right? As soon as we encounter asterisk, we remove the first character which was entered into the stack, or the last character which is present in the top of the stack. Again, we encounter asterisk, this gets removed, right? Then we have a character, we enter it E, then F, right? So this is the thing. And when you take out the elements from the stack, F, E, B, then it's C, right? This is the output. Now we will have a question that when we pop elements out, it basically in reverse order. So we have to reverse it after that, right? But in Python, since we use array or list as a implementation of stack, so we don't have to think about it. We just have to know the logic of stack, and we will just pop the elements from the first and do the thing. We don't have to reverse it again. So it saves our time complexity also. So what we figure out from here, the stack behaves like a SAM's writing process, and it ensures every star removes the correct letter, the one immediately before it, and at the end we combine all the remaining letters in a stack to form the final message. Right? I hope you understood the intuition and how we built up the intuition and how we got the thought that why we are using stack here and how it is a stack implemented question. So now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach how we're going to solve it. So first we will initialize an empty stack. We create an empty list called stack. Yes, in Python, mostly we use a list for the implementation of stack because you don't have an inbuilt library for stack in Python. So the stack works like a dynamic writing pad. You can add letters to the end and remove the last letter from any unit, like. And we iterate through the each character after that. Stack is implemented, declared. Then we iterate through the each character in the array and using a loop and go through each character in the input string using for loop, right? That's the thing. We go for like these are the characters and you go through the string and you keep on pushing it into the stack. If it is a character, you can see it here. We handle each character based on its type. If a character is a letter which is not a star, we simply push it into the stack and basically appending into the list of named stack because it is a valid character. And remember, since we are using list, we will push it from the back, right? And we will do the pop. When we do pop, it's basically pops from the back, right? You don't have to touch the front end or anything. Just move with the back end part. And if the character is a star, first check if the stack is not empty. For example, by chance, if the stack is empty, so you cannot pop anything, right? And it kind of becomes invalid. But our question says that the number of stars and the number of characters will be equal. Basically, there won't be any invalid cases as such. Fine. So we will just check for our safety concerns. Otherwise, it's not necessary. We will do pop, and this means that we need to delete the most recently added non-stack character, right? And pop removes the last character from the stack. Now, finally, after the loop is complete, the stack will contain all the characters that haven't been removed by any star. Fine. So, and like at the end, this will contain some characters which don't have. The list will be containing characters with no stars. Fine. So this is our output. So we use join. Basically, join does what? It takes the list. It joins the complete character, and since I'm using an empty string here, so there would not be any space between the characters. It will basically all together. So basically, it will convert it to a list of. It will basically convert the list into a string. Okay, fine. This is what join will do. And the stack is a list of characters, and join merges them into a single string. Fine. I hope you understood the approach. It's very simple and clear as soon as you understand that this is a question of stack implementation. Fine. If you can see how stack is helping us, right? Let's take a revision in a nutshell. It follows a rule of last in, first out, which matches the problem exactly. The last character in should be the first character out. Correct? Every time we see a star, we need to remove the last added character. That is exactly the stack is used for and build up for here in this case. Yeah. So avoiding the complicated index tracking or doing slicing, we don't need to do string slicing and or keeping the indexes in our dictionary and storing. We don't have to do some gibberish work and all that stuff. We just without a stack, we could with a stack we could do it very easily, right? So otherwise it will be manually finding and removing the correct characters from using a string slicing and all that stuff. It becomes messy and slow. And efficient one pass solution, it takes only one pass to complete the problem, right? So the stack lets us process a string in just one loop from left to right. We no need to go to back and search again, right? Or make it to iteration of n square solution. You also know where the last character it is. It's on the top of the stack. So using stack here makes the question very, very, very easy, right? Don't have to think twice of using any other data structures here as soon as you understand what's happening right down in the problem. Fine. I hope you understood the approach explanation. Now let's move to the next slide. The code is an exact copy of the approach discussed. Let's understand it line by line. Okay, so we initialize name stack variable name with a list. So that we can understand, we can have the feeling of stack with the word, and we can so that we know what we are using and why we are using, and we can use the philosophy of stack, right? So a character in S, we iterate to the list given, string given. If it is a star or asterisk, first we check whether the list is empty or not. If it is empty, we cannot pop, right? But if stack contains some values, so we can pop them. And if it is not an asterisk, we just push the element to the stack. So the pushing is done from the backside and popping also done from the backside. Fine. And at the end, we convert it into a string and use join function here so that list converts into a string with zero spaces. Fine. So yeah, the total time complexity then comes out to be O of n because we are only doing one pass of length n, if you can see, right? And space complexity is O of n, reason being we are using a list data structure here to store the elements. Even though we are not returning list at the end, but we are using it to store the elements, right? So it becomes O of n, and yeah, at the end we return it. So the space complexity is O of n, and time complexity is also O of n. I hope you understood the code explanation. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Fine. So let's take this example lead, one more asterisk, code, one more asterisk and e. Fine. Great. So what our problem was doing, first we were initializing a stack. Let me write it here, stack. Okay, then what we were doing, we were iterating to this string, right? And we remember if it is a character or a letter, basically not an asterisk, we were pushing it into the stack. So we push it from the back. So I will write it here, okay? Or let me make it more practical so that you could understand. So L is added here. Great. We push it from the back, right? Then we move ahead. Again, it is a character, so we push it from the back. Again, it is in character, we push it from the back. Okay. Now we'll just clear this and make some space here. So after pushing, it becomes this way, right? Then T, it is also a character, so it also gets pushed in the back. Fine. Now asterisk. Okay. Now what we will do when we encounter asterisk, we should check whether the list is empty or not. Since it is not empty, we will just pop it from the back. So what we do, we pop. Popping is done, which means T gets removed. Correct. Again, we moved ahead. We see okay, another asterisk is there. So top best element right now is E, right? So E gets removed. Then we come in C. It's in letter, not an asterisk, so gets pushed in the back. O also get pushed. D also get pushed, right? So if you can see, we are encounter asterisk after that, right? So the topmost element right now is B, it gets removed. Then we have E. E gets pushed, right? This is our final, I could say list or stack, fine. So what we do, what we do, we just join it, fine. So the output becomes fine. This is our output. Okay. So I hope you understood the dry run. Dry run is pretty simple and pretty easy, right? I hope you understood it. So if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition and the approach and then the code. After that, do a dry run by yourself on 2, 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Okay, now let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. So first, we will declare a stack or a list, you could say. Okay. Then when we will iterate for character in S, then we will check if character, we'll check if the character, if it is an asterisk, fine. Then we check if stack is not empty or not. If stack is true, means size is there, means it is not empty. So what we did, we popped stack dot pop, correct? Else, this is done. Else, what we did, stack dot append the character, and at the end we just return uh, dot join stack. Let's submit the solution and check. Okay, it got passed. Now let's submit. Okay, we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.